Going on now to our last chapter that we'll be covering in Math 1103, which is chapter 5. We're going to be doing 6 sections, the first 6 sections of chapter 5 that are listed here, and we'll move on to them right now. So, we're going to start off with something we already did, which was exponential notation back in section 4 of chapter 1. And as we look at it, if we take a factor 2 and multiply it by itself 5 times, a shorthand notation for this is to write it in exponential notation, where 5 is the number of times the base 2 has been multiplied by itself, which is, this is in longhand, this would be in shorthand, and it's called exponential notation, where 2 is the base and 5 is the number of times it's multiplied by itself, and it's referred to as an exponent. So 5 to the 6th power would be this. Now, -3, interestingly, in parentheses, indicates that it's a -3, that's the base. So it's going to be a -3 multiplied by itself, and it becomes an even number. Okay, so there's the base, and then there's the exponent. So let's do a few of these. Now, here it's going to be 2 as the base to the 3rd power. So we're multiplying 2 by itself 3 times, that's 8. Now, it's not 2 times 3. It's 2 times 2 times 2. Now, every number has an exponent of 1 that we don't write usually, so this is just a 3. Now here we have the quantity in parentheses, a -4. That's our base. So -4 squared is 16. Now here, this one's a little tricky, and you might say, aren't they the same? Well, no, they're not. Because here the base is only the 4. So we square 4 and get 16. Then we apply the negative sign, and that's what it gives us. Now here, both of them are squared, or to the 4th power, I should say. 1 to the 4th is 1, and 2 to the 4th is 16. Now here, this is interesting because it's 0.5. Well, 0.5 times 0.5 is 0.25. 0.25 times 0.5 is 0.125. So this is a perfect cube here. Perfect fourth, a perfect square. This is just to the 1st power. This is a perfect cube. Now, in doing something like this, you might say, do you go 4 times 3 first? No, you go 3 to the 2nd first. Remember, please excuse my dear Aunt Sally. So parentheses, grouping symbols, exponents first, then multiplication. So this is 9 times 4 will be 36. And you'll have some practice as you go through your practice and quiz bees. And here they're pointing out some little helpful hints that here it's a -3. That's your base. That's squared. Here only the 3 is the base. Then you apply the negative sign. So this is sort of a general way of writing exponential notation, and the exponent indicates the number of times the base is used as a factor. Okay, example 2. Here they want you to evaluate when x is a 5. So writing it out, good technique. Hopefully you're keeping your homework logs. That would be 2 times our x is 5 that we're going to raise to the third power. So 5 to the third is 125 times 2 is 250. And they have it worked out here for you. Now here it's 9 over a -3 squared. Now since x is a -3, I put it in the parenthesis because that's your base now. When you square a -3, you get a +9, and that equals 1. Okay, now there's some other rules that we'll be looking at. There's the product rule, that if we are multiplying where our base is the same, the rule for doing this is that there's 4 of these, there's 3 of those. So to put this in exponential notation, you're going to end up with 7 of them. So what technique would you use? Well, for the product rule, when our bases are the same and we're multiplying them, we just add our exponent. Bases are the same, we just add our exponent. Now the rule is given down below here. A to the m times a to the n equals a to the sum of the exponents, okay? Now, a helpful hint here is note that you do not change the bases. Here, that's why this is wrong. They multiplied 3 times 3. Can't do that. You're just adding your exponents, okay? Example 3, and we're going to use now the product rule. And they do want us to simplify too, so, okay. All right, so for something like letter A, this is going to be 4, add the exponents to the 7th. And they're leaving it that way, so they're not expanding that. This is going to be x to the 10th. Remember, there's a 1 over there. Y to the 4th. So 5 plus 7, y to the 12th. This is going to be a -5 to the 15th. And here, notice they are different bases. So that's as far as you can go. And they have it worked out here for you. Again, some of this stuff is pretty easy. And you're just recalling it from probably your high school algebra. Example 4. Now, here's something a little different. Here we have exponents on the bases, but then we also have numbers. So the rule is, here we're going to multiply the coefficients, So we go 2 times a negative 3 gives us a negative 6, and then we add our exponents, x to the 5th. Well, how about 2 plus 5, x to the 7th? Yeah, that would be much better. 2 plus, no, I was thinking this 3 here. Okay, but anyway, there's the answer. Better do the practice here. Negative times negative will give you a positive 15 y to the 7th. Just adding your exponents. So for something like this, we're going to add our exponents. Our bases here are the same. X to the 5th. Remember there's a 1 there. Y to the 3rd. Now there's a 1 out in front of the A. So that's a negative 1 times 3 gives us a negative 3. A, and there's a 1 there, to the 8th. B to the 13th. Okay, they're right there too. Now, notice what you're doing here. You're not multiplying, you're adding. So when we add letters, we only deal with the numerical coefficients. So this is going to be 8x to the 3rd. The variable does not change when we add. And here we can't add because they're not like terms. Now when we multiply the numerical coefficients and we multiply the variables by adding the exponents. Okay? So note the difference here. I think this is a useful thing to look at and get it. Okay, let's go on to objective 3 now. And here we're using what is called the power rule. Now in the power rule, it's a little different. Here we're taking x squared as our base and raising it to the 3rd power, which means this is like this. And if you did this, this would become x to the 6th. Now, keeping that in mind, how would you get it from this? Well, here we wouldn't add exponents. When we're raising a power to a power, we multiply exponents. 2 times 3 gives us the 6. Okay? And they're kind of showing it to us here. And here's the rule. You want to include that in your notes. Now remember, anytime you want to pause the tape to take notes, just do that. Pause it. So again, this example, 2 times 5 would give you 7 to the 10th. Okay, let's do these over here. This is going to be y to the what? And this is going to be 8 to the what? Now, this is going to be a negative 5 to the what here? 21st. And these are short, so we get z to the 21st, 4 to the 18th, and a negative 2 to the 15th. You're just multiplying the exponents when you have something in a parenthesis and you're raising it to a power. This is the power rule. And again, lots of little helpful hints. Now, suppose there's more than one item in a parenthesis. Well, for something like this, just imagine there's a 1 by each of these variables. So it's 1 times 3 is 3. 1 times 3 is 3. This is what you get. So the rule is, when you have something like this, the exponent then applies to each of these factors. And here they're showing you this rule. Power of a product rule. Now, when we have this example, let me write it here, 3x to the 5th, keep in mind there's an exponent by the 3 of 1. There's an exponent there. So this becomes then 3 to the 5th x to the 5th. And 3 to the 5th is a rather large number. Okay, they're showing you that right here. All right, let's do some examples. Here we have s to the 4th, t to the 4th. Remember, there's a 1 by each of those. There's a 1 there. So we're going to get 2 to the 3rd, a to the 3rd. And it looks like they want you to expand that 2 to the 3rd to 8. This is going to be, again, it's sort of a 1/3 squared, which is 1/9. There's a 1 there that gives me an m squared, n to the 6th. 3 times 2 is 6. Now, something we may or may not have mentioned earlier, if you are squaring or raising to an even power, something that is negative, it's going to become positive because you have a negative times a negative. So this becomes positive. And then 5 squared is 25. X just multiplied to the 4th. Y to the 6th. Z to the 2nd. Okay, let's do this one too, since it's right here. P to the 5th, R to the 5th. 6 squared is 36. B to the 2nd. 1/4 to the 3rd is 1 times 1 times 1 is 1. 4 to the 3rd, I happen to know, is 64. X to the 6th, Y to the 3rd. Now again, raising something that's negative to the 4th power, an even number, makes it positive. So 3 to the 4th is 81. A to the 12th. B to the 16th. C to the 4th. Okay. Now we did a little bit of this, but they're going to give us its own section here. And when you have a fraction in a parenthesis that's raised to a power, it applies to both the numerator and denominator. That's what they're showing here. That's called the quotient rule. And remember, C cannot be equal to 0. Otherwise, that would be undefined. So as we look at example 8, this will be m to the 7th over n to the 7th. And this is going to be x to the 12th, just multiplying, and then 4 to the 3rd is 81. y to the 20th. Now, if there were some common fractions here, we could simplify, but we don't see any yet here. Okay. And then this one is x to the 5th, y to the 10th, and then 2 to the 5th I happen to know is 32, a to the 20th over b to the 15th. All right, we're looking at another major area here too, which is using the quotient rule and defining the zero exponent. So if we are dividing instead of multiplying and our bases are the same, notice that's what this looks like, that's what this looks like. Now we have three combinations of x over x. These are all just ones. So we're left with x to the second, as they show down here. Now a shortcut way to get to it would be to take, and I've mentioned this before, an exponent from where it is in the denominator, cross the numerator, well, cross the division bar into the numerator. When you do so, the sign of the exponent changes. And that gives you, where it was positive there, here it's negative. 5 minus 3, that's what gives you x to the second. And that's what they're showing you here. Okay? So if multiplication is adding, I think you can see that division must be subtracting, which is what they're showing. So example 9, simplify each quotient. Let's just do that. And we could raise it up a little bit. Here we're just going to subtract the 2 from the 5, x to the third, 4 to the fourth, a negative 3 to the third. Now here they're not like bases, so we can't do anything with that one. Now here we're left with a 2 for the number, but there's a 1 there. Up there becomes a negative 1, so x to the fourth, y. Okay. We've done some practice, and you will be doing practice. Now, an interesting thing happens when we do something like this. Let me just show you. It's down here. But if we had x to the third divided by x to the third, that would be x to the third minus 3, right, if we brought that up, which would then be x to the 0. Now, what did we always say, as long as there's not a 0 in the denominator? Anything divided by itself, we said was what? 1. So here, this divided by this is 1. And if we use this, to use what we've done up here, we get x to the 0. What is anything to the 0 power? And the answer is always going to be 1. Anything to the 0 power is 1. Okay, now it can be a little tricky. So let's take a look at these examples here. Three to the 0, 1. This to the 0, 1. this to the 0, 1. Here's where it's a little tricky, because our base here is -5. What is our base here? Only the 5. So 5 to the 0 is 1. Then we apply the negative sign. Now any fraction to the 0 power is 1. Now what is our base here? X. That's the only thing that's to the 0 power. So our x here is 1. 1 times 4, though, gives us a 4. Now, if this were 4x to the 0, like so, where your base is 4x, that would equal 1. But here, since it's not in parentheses, the only thing we have as our base is x. That's 1. Times 4 is 4. Okay? Take a look at this one down here. What's this one going to be? -1. Because the 3 to the 0 is 1. Then you apply the negative. This is going to be a 1. 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 What will this one be? 7. Because y to the 0 power is 1. 1 times 7 is 7. Okay, so a little more of a challenge now as we go on. They're wondering, deciding which rule to use. So this is going to be sort of a mixed bag. Here we're just going to add, and we get x to the 11th. Here we're going to raise to the 4th, t to the 4th, and then 2 to the 4th happens to be 16. And then here now we're going to square the 9 and get 81, y to the 10th. Here we're multiplying. And they did all of these, so we're good. And that's where your practice and then your quiz bee is used. This is sort of a long session here. I thought it would be a little shorter. Okay, well, we're almost finished anyway. So simplify each expression. Okay, so what is this here? Just 4 squared is 16 minus 1. So this will be 15. Now, x to the 0 power is 1. 1 cubed is 1. Plus, this is 1 to the 5th is 1. So 1 times 1 is 2. Here we have our answers here. Now, an interesting thing can go on. When this is squared up here, you can actually do some simplification here. This can become a 1, and this will become a 2. We just simplified that a little bit. Can't do anything with the letters. So our top here is going to be y to the 14th. And our bottom will be 2 squared is 4. X 5 times 2 is 10. That's letter C here. Yep. Now notice they did expand that, and they got this, and they just had to cancel it out later, which is, we did it already, which is okay to do. Now here you can't do it because the 2 is inside here. Theoretically, we're going to do something later. So this is going to become an 8. 2 to the 3rd is 8. A to the 9th. B to the 12th. And then that's all. There's no more letters. Sorry. And then this is going to be a negative 8 here. A to the ninth, B to the second. Okay, well, the a to the ninths are going to cancel out. That's just a 1. This is going to become a negative 1 here. And then we're going to get B. I see what I did here. B to the 10th. You can use that here. So we're going to subtract the 2 from the 12 and get a 10. These cancel out completely, and here I have a positive 8 divided by a negative 8, which is a negative 1 that we don't write. Okay. And I guess that's it. Okay, well, lots of practice. Learn your skills. It's not too hard, but there's a couple of different rules in there.